All right, so 9.5, we talked about polar coordinates, how to plot a polar coordinate, how to convert a polar coordinate to rectangular, rectangular to polar, and how to find additional coordinates, kind of using that coterminal thought process. So this says plot a point and find three additional polar representations of the point using negative 2 pi is less than theta, which is less than 2 pi. Then find the rectangular coordinates for the point. So you've got your point. It's 2 pi over 3. So the first thing you want to do is actually plot it. Okay, 2 pi over 3 is here. And then 4 being the radius, 1, 2, 3, 4. That's that last ring as you move out. Okay, that would be your original point, 2 pi over 3. And then it says find 3 additional polar representations of the point. So remember, there's 2 ways to do this. The first way is to keep the r as it is and add and subtract 2 pi. So if I were to leave r as positive 4, if I take 2 pi over 3 and add 2 pi, or 6 pi over 3, I get 8 pi over 3, which does not fall in the range of negative 2 pi to positive 2 pi. So I can't use that one. So then I can try subtracting 2 pi from it, or 6 pi over 3. And I get negative 4 pi over 3, which does fall in that range. So negative 4 pi over 3, with the radius the same of 4, is the first additional polar point. Then I can, because if I subtract 2 pi again, it's going to be too small, right? So the other method is to change the sign on the r. So my r would become negative 4, and then add and subtract odd multiples of pi. So if I take 2 pi over 3 and I add pi to it, or 3 pi over 3, I get 5 pi over 3, which is less than 2 pi. So that works. And then if I were to add, subtract pi, which would be 3 pi over 3, I'd get negative pi over 3, which also falls in that range. So I'm doing odd multiples of pi, which means that I'm changing the sign on the radius, and then the odd multiple minus, or subtracted from it, gives me negative pi over 3. So my 3 additional representations of that same point are these 3. And again, remember, you can check them. So I can plot them and I can make sure that they overlap with the same thing. So if I did negative 4 pi over 3, I'd go negative, which is in this direction. I'd land on the same angle. I'd go out in the same direction 4 units, and I'd get the same point. If you do the second one, 5 pi over 3 is actually over here. But the negative tells you to move away from that 4 units, and I'd end up in the same spot. And then negative pi over 3 is also in that same spot as 5 pi over 3, because you're going negative. And then moving away, it's negative, so I'm moving away from it to the same spot. The last thing on this says find the rectangular coordinates for the point. So remember, when we're converting from polar to rectangular, that I'm looking for an x and a y, and the x equals the cos r times the cosine of theta, and y equals r times the sine of theta. So I'd get 4 cosine 2 pi over 3, and I'd get 4 sine 2 pi over 3. 2 pi over 3, which was on my unit circle here, is that second pi over 3 that you hit. The over 3s are 1/2 root 3 over 2. And it's in the second quadrant, so that 1/2 is negative. So then I'd get 4 times negative 1/2, and 4 times positive 3 root 3 over 2. This simplifies to negative 2. This simplifies to 2 root 3. So my xy, which you always want to write what it is negative 2 and 2 root 3. Questions on that one? How many of you got it right? Okay, good. All right, second one says plot the given point in the rectangular coordinate and then find 2 additional sets of polar coordinates for the point 0 and less than or equal to 0. That should actually be less than. Actually, no, it's fine. Less than or equal to theta, which is less than 2 pi. I'm going to leave it there and tell you why. So the first thing you would do is if I was on a rectangular coordinate grid, let me double that on top of this. So when I plot that, it would be negative square root 3 and negative 1. I'm going to approximate square root 3. It's in between square root 1 and square root 4. So it's in between 1 and 2, closer to 2. So let's just say this is like a 1.7, 1.8. Okay, so negative 1.7 and negative 1 would be here. So the first thing that tells me is that when I look at my answer at the end, and I'm looking for the polar points, that should be in the third quadrant. Okay, to go from rectangular to polar, I have to find theta, and the tangent of theta is y over x. And I have to find r squared equals a squared plus b squared. So if the tangent of theta is negative 1 over negative root 3, that's saying that the tangent of theta is positive 1 over root 3. That's the one that's going to get rationalized, right? So this is the same thing as saying tangent of theta would be root 3 over 3. Without a calculator, you're going to have a limited number of those, right? Because you can only have tangent be 0, undefined, root 3 over 3, root 3, or 1. So there's a limited amount that you have to do. You just have to figure out there's always going to be two answers here. So the root 3 over 3 is your over 6's. And if it's positive, we're talking quadrant 1 and quadrant 3. But how do I know which one to pick? Let me go.
Quadrant 3 because it's like where the rectangular point is.
Good. So if I plot it, which it did, right? It's in the third quadrant, which tells you I'm going to pick the over 6 that's in the third quadrant. And there's over 6 that's in the third quadrant is 7 pi over 6. So now I know theta is 7 pi over 6. With me so far? Okay. Then I want to find the radius. So I would do r squared equals a squared, this is x and y. A squared plus b squared, or x and y. And that's negative root 3 squared plus negative 1 squared. This is 3 plus 1, which is 4. R squared equals 4, which means r equals 2. Now I've got my coordinate points, and I want it in polar. So I'm going to say r comma theta equals 2, 7 pi over 6. And then it says find two sets of polar coordinates for the point. So I have the first one. This time it needs to be in between 0 and 2 pi. So if I look at what's here, okay, I again have two choices. Leave the r the same, add or subtract 2 pi, or change the r, add and subtract pi. If I add 2 pi to 7 pi over 6, it's too big. If I subtract 2 pi from it, or 12 pi over 6, this time I need it to be bigger than 0, so that's too small, right? If I add it, I didn't show it, but if I add it, it's too big, which means I have to go the other route. Change the sign on the r, so r theta has to start with a negative 2, and then add or subtract pi. If I add pi, which is 6 pi over 6, it's 13 pi over 6, that's too big. But if I subtract pi, I get pi over 6, which falls in between 0 and 2 pi. So here's my initial coordinate. Here's my additional point. And if I wanted to graph that, if you wanted to go back to the polar graph, I can either go 7 pi over 6 or pi over 6. It doesn't matter. Okay, 7 pi over 6 is here. And 2 would be out to the second ring. If I had done pi over 6, which would have been here, the radius would have been negative. I would have moved away. It still would have given me that same coordinate point. Questions on that one? Okay, so then the homework question said plot the point given in rectangular coordinates. So you were fine on the plotting? Yeah. It was the conversion. Okay, find two sets of polar coordinates for the point that fall between 0 and 2 pi. Oh, and this is the same set of directions as the warm-up. So what that means is your answer could have been 0. Okay, so it can't be 2 pi, but it could be 0. So just pay attention to the actual signs there. If you think about the range, when we used to do this in interval notation, this would be the same thing as saying 0 to 2 pi, where 0 gets a bracket, but 2 pi gets a parentheses. So if 0 was an answer that you got, you could have kept it. 2 pi would have, you couldn't have kept it. All right, so I'm going to convert this. So the tangent of theta equals negative 6 over 6 root 3, which means the tangent is negative 1 over root 3, or negative root 3 over 3. So I know it's an over 6, and I know it's going to be one in which tangent's negative, which is going to be in the second quadrant and the fourth quadrant. So this would be 5 pi over 6, and this would be 11 pi over 6. And then based on the location of my initial coordinate, which is a positive x and a negative y, positive x, negative y, means I'm in the third quadrant. So then I'd get, what was my, oh, you also had to find the radius. So r squared equals x squared plus y squared. And I'd get 36 times 3, 108 plus 36, 144, square root of that is 12. Okay, so my initial point would be 12 and 11 pi over 6. But then it also wanted an additional one between 0 and, oh, you just picked the wrong angles, right? You picked it over 3s instead of over 6s. I also needed an extra one inside the 0 to 2 pi range. If you add 2 pi, if you keep r the same, you add 2 pi, it's too big. You subtract 2 pi, it's too small, which means you have to change the sign on the 12 to be negative, and then add or subtract pi. If I add pi, it's too big, but if I subtract pi, or 6 pi over 6, I get 5 pi over 6, which is the other working angle. So these two are your polar representations that you can use, and it just said put it smaller than larger. So the first one, the negative comes first. Questions?